Let's work on finding average rates of change and instantaneous rates of change for these linear motion problems. So let S at t here represent the position of a particle in meters, and t represent the time in seconds. It wants you to find the acceleration of the function from t is equal to 2 to t is equal to 4, and find the acceleration at t is equal to 3. So what's important to distinguish is, one, the first kind has between 2 points in time, so that is obviously discussing an average rate of change. And because the second acceleration that it asks for, it's asking for one specific point in time, that means it's asking for an instantaneous rate of change. Because it's asking for acceleration, acceleration is the rate of change of the velocity function. So to calculate A average, we're going to find v at t2 minus v at t1 over t2 minus t1. And to find A instantaneous, we're going to find simply A prime, or sorry, v prime at t. So in order to do this, we're going to need first the velocity function. So the velocity function v at t is found by taking the derivative of the position function. We can calculate that because it's simply power rule, so we get 12t squared minus 18t minus 30. So that is our position, or our velocity function. Now let's calculate the average rate of change. So it's v at t2. V at t2 would be v at 4 minus v at 2 over all over 4 minus 2. So v at 4, when you sub in 4 into your question, so into here, when you sub in 4 in there, you get 30 meters per second. Then if you were to sub in 2, you get negative 18 meters per second. And then 4 minus 2, of course, 2. So you get 30 minus negative 18 is 48. Divide that by 2 and you get 24 meters per second squared. Remember, acceleration is measured in meters per second squared. But if you want the instantaneous acceleration, because it's at one point of time, 3 seconds, then you want to be finding the derivative. So A instantaneous is going to be equal to v prime at t. So that's the derivative of 12t squared minus 18t minus 30. So we can take the derivative there. We get 24t minus 18. And so that is A at t. And now we can go and sub that in. We can sub in 3 seconds. So A at 3 is equal to 24 times 3 minus 18. And then when you sub that in, 24 times 3 minus 18, you get 54 meters per second squared. So that's the difference between an average rate of change and an instantaneous rate of change. Notice, you'll want to be noticing the 2 points in time versus the 1 point in time.